Thank you for your patience. Welcome to APPA's weekly webinar. My name is Billy Zadig, Manager, Special Projects for APPA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to the APPA webpage later this afternoon. You will receive a follow-up email in the next couple of days with a link to the webpage where all webinar recordings are housed, as well as a link to our upcoming webinars. We have webinars planned out through 2021 and are open for registration. Professional Continuing Education and AIA-CLU credits are being offered for today's program. If you are an AIA professional requiring a certificate, please send an email to me at Billie, B-I-L-L-I-E, @appa.org, along with your AIA membership number if you have not done so in the past. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly. If we still have questions, responses will be sent directly to the person asking the question by our presenter. If you are just calling in, make sure to send me an email at billie@appa.org so I can send you your certificate if you requested one. The system only recognizes you if you log in. At this time, it's my pleasure to turn this over to Colleen McCain, who will introduce our speaker for today. I will rejoin you for the Q&A session later on. Colleen, take it away.
Thanks so much, Billie, for that intro. Like Billie mentioned, I'm Colleen McCain. I'm the Marketing and Membership Engagement Manager with the 3 Leaders in Building Performance for the AABC, Associated Air Balance Council, AABC Commissioning Group, ACG, and also EMA, Energy Management Association. Collectively known as the Leaders in Building Performance, these 3 associations represent more than 600 member companies and 2,500 certified professionals in the commissioning, energy management, and testing, adjusting, and balancing disciplines. Now, I'd like to introduce you to today's presenter and ACG member, Raj Sethi. Raj is a 1992 graduate of UC Davis, currently serves as president of Sethi & Associates International, a DC-based engineering firm with 9 offices, CEO of Cyclops, a digital twin facilities company. He is on the ASHRAE Epidemic Task Force for schools and helped write much of the reopening guidelines for schools in the COVID pandemic. Clients include over 20 universities, hospital systems, dozens of school districts, and large corporations and governments. Without further ado, here is Raj Sethi. Take it away, Raj.
All right, good afternoon. Apologize for the delay, that was on my end. So today we're going to start to go through what is a digital twin. We're going to talk about some of the data streams, and then I'm going to walk you through KIPP schools, which is a large charter school operation that's here throughout the US. So some of the learning objectives, have you understand what a digital twin is and where it is going, where the marketplace is going. Try to get a sense of the data mapping process. Define how we set up a digital twin, and then you're going to start to see how the different data streams get correlated. With KIPP, we're heavily going to talk about the TCO. That's where we initially started, the total cost of ownership. And then from there, how we've expanded our digital twin services with them. All right, we're in the world now where data is ubiquitous, but the problem is if data technology doesn't make your lives easier, then you need to jettison it. And that's where the world of a digital twin has come in to make it simpler. So who is KIPP? KIPP is a school system heavily focused in the DC area. It's a charter school system, I believe, across the country. They have 135 schools in the DC area. They have around 18 schools. We have started with 4 of their schools, putting it into Cyclops. Our main needs are this total cost of ownership, financial forecasting. How they did it in the past was they do a facility condition assessment every 5 years, then they use that for their budgeting. It was very difficult to get to the granularity and also the accuracy. So we need to have a better way of figuring out when their assets are going to need to be replaced and to define their useful life. So we are building it from an asset centric view heavily on the HVAC. Me being a mechanical engineer, that's where we get pulled in quite a bit. So what is a digital twin? A digital twin, as Forbes defines it, is a virtual model or a process where you pair the virtual and the physical worlds together. The digital twins really got their start with NASA and offshore oil rigs, where they're trying to simulate different things that these products would see. So now we're moving into the world of static buildings as well as looking at our complicated systems. It is so deep now. It's no longer cutting edge in the sense of digital twins. It is cutting edge in the sense of our buildings, but even Microsoft Azure has a massive digital twin platform for programmers, setting it up like tools that Autodesk products and some of the other products can go right into. So we've reached that point. So the analog, like every industry, we're going from analog to digital. So you have the analog at the top, the physical building. We've done a good job in our industry to move to building using digital products like BIM, like calculators, the entire world of computers now on how we expedite our construction processes with apps and the visualization. And now we're moving into taking IoT sensors and other data feeds and starting to put it into a facilities model digital twin. So you see how that thing works and acts in the real world. Where we want to get to at the end of all of this effort is, can the building and you as the operator owner start to communicate with it? Can you ask it questions? Twin, if I have a single point of failure, can you show me? Twin, if we have an extra $50,000 budget, what would you recommend placing that money on? So this is where the end game is by taking the data into the AI platform. You're going to hear lots and lots in this coming world about artificial intelligence and machine learning. To have good artificial intelligence and machine learning, you need, its food is data. So we have to start to ingest this data in a format that is usable to make those decisions. So starting to look at the data feeds, if you think about a building, we have all these different platforms now. One of the things that KIPP and a lot of the owners that are using the twin are struggling with is just the amount of different software platforms. The logins from their accounting system to the fire alarm system to their lighting systems to their control systems to their work order systems. So all of these are going to be harnessed and normalized and put into a single platform, which I'm going to show you momentarily. What is the other piece that a lot of these entities are starting to run into? Qualified staff are retiring. I was at a conference last week, and one of the universities had over a 30% vacancy rate for facility staff. We're not going to be able to replace these folks very easily. There's a tremendous amount of institutional knowledge that's being lost. And if you think about how most of the questions are answered now, if you need to change a valve or shut off valve, it's all about, well, I think John knows where it is or he worked on it. That's not scalable, and that represents a very risky position for someone like KIPP, for a lot of building asset owners and operators. Buildings are also getting older and the systems are very complicated. We are putting in more and more sensors. You can't buy a toaster anymore without a PLC, programmable logical controller. So all of these are leading to this place where we need a better way. We say we've got lots of tools, we say we've got lots of sensors, but yet the building management has not gotten better. It's gotten worse, in my opinion. The realities today are the consumer, your owner, your building occupant, they're expecting things to get repaired faster, and they need to have a sense of how these are going to not impact their business operations. For a school in this scenario, There's no way that we can have a school go out because there's no heating systems. A lot of the systems in the past were very simple and dumb, for lack of a better term, that would just operate. Now we're at a place where a lot of the problems are occurring because a control board goes bad. Not the pump, not the air handler, not the fan, but the software side is what's driving some of the outages. So we need to get a better sense of how to predict and how to maintain these, and the durability of these products over time has to go back into some system for the transfer of knowledge. So then how do we develop the twin? What we see with the twin is more about a very robust dashboard, and we want the twin, we start with a BIM model, we end up porting it into a game engine, and then we start to tie in all the various software applications that feed into your building, whether it's the controls, in KIPP's case, the accounting system, their work order system, and then we start to create these FCAs, facility condition assessments, views, and several of these items are still in their preliminary phase as we start to work out the software handshake, and the labeling, we call it like a project haystack, is out in the marketplace, which labels what an air handler is on the software side. So those are the things that we're working through. But as we start getting those done, we're seeing the end game with that. So what are the main data sources to have a successful twin? You need your work order system. That's a data point. You need your accounting system, which covers your money, covers your costs, covers your contracts, your work order history. Then we have the IoT, which is your real-time data for sensors, for occupancy. And finally, we have the controls, which is made up of all of your physical data like cut sheets, how to fix it, your staff, their institutional knowledge, and then of course all of the way the designers and the way the systems are supposed to operate in unison. Often the IoT sensors are about assets, and then the controls are going to be more about your systems, so your chilled water system versus your chiller. So what does the twin look like? It is basically taking the BIM model, which I talked about, and go into a game engine, and then you're going to fly around this building. We're going to try to troubleshoot and figure out what your points of risks are, what your most expensive assets are, where do you need to put your focus on as a building operator. You're never going to replace the guys in the field, but we need to arm them with better data about where to go on a day-to-day basis. Can we fix it here online before we actually go out to the field? The way we've set up the twin is to be asset-centric. So the first inefficiency that we removed was just having everything that's associated with their large capital equipment in one singular place. There isn't a Windows Explorer drive where they have to go in and figure out where are the cut sheets, what are the most logical, or what are the most up-to-date plans. We want to try to remove some of those questions that represent inefficiency. What is the date of install? What's our expected end of life? Is my preventative maintenance being done? Answering all these questions is what the principal wants to see. They want to see all of those parts and pieces about how their building is operating. So how are we doing that? So the second piece, sorry, let me back up for a second. So the other piece is the total cost of ownership. APA has created a wonderful standard on the total cost of ownership, which we have now in essence coded into graphical tree maps and heat maps. So what KIPP wanted to see is on a monthly basis, what is my most expensive month? So how can we pull that from the accounting cost data? And then as we pull the data from the accounting system, we start to codify it into these buckets down here: electricity costs, custodial, elevators, and this is what they wanted. And so from here, we're able to then drill down into getting a better sense if things are on track, off track. As the data builds up over time, the ultimate goal is to project or predict what their costs will be for architectural maintenance in 2026, as an example. And nothing's perfect, but it does give you a better baseline than what they were doing in the past, which was taking each category and then increasing it by 5% or to inflation. The structure of the TCO on how we've coded it up has all been laid out in the APA guideline, and that's what we're trying to use these protocols as a great road map on how to start to quantify and also how to code all this up. So that's all within this APA guideline. So we're trying to get out of just running your building by spreadsheets, and that's it can be done, but at the same time, it's not scalable, and the spreadsheets leave a lot to be desired and developed. So moving from a system of record to a system of insight also. So here we're looking at some historical data of their costs to maintain their building, and you're going to see things go up, go down, and ultimately the goal is to try to normalize it and start to get a sense of what the projected costs of that building will be based on their historical data, and then based on when the equipment useful life is going to hit. So again, you can run this in a spreadsheet, but at the same time, when it becomes real live connections into their accounting software systems, and it's coded in the same way. If custodial, there's a I will say a lab fire because a student set something on fire, so that will end up getting coded in here, and then you can start to normalize that anomaly out if you have to renovate that lab, as an example. The second piece that's coming out of this is when things are going south for the total cost of ownership is the time down, the time that they can't use a classroom, can't use one of their assets, facilities, is going to be a cost that we're going to have to quantify. And where our goal is to help the technician, help the operators fix it faster. We need to get our work orders down because the complexity has increased, but the work order time has started to get higher. We need to drive that time down. So having the parts, having videos from the operations and maintenance handover easily accessible in the twin, those are all parts and pieces that we're going to start to develop and put into the twin. Imagine at the turnover of your building, you get a CD of 180 hours of videos. And so it's not very user-friendly. You just need to get a little YouTube type snip of how to change a set point, how to, like this example, how to refill the refrigerant. So if we can start to put that information into very simple, kind of accessible ways, then we're going to be able to also then change our TCO, which is our total cost of ownership profile. Again, this is one of those things that we're seeing as an outflow of that. Next piece is what they would like is to see if they can shorten the time or the risk in when they ask a contractor to come to the site to fix things. Again, under the full theme of TCO, total cost of ownership, one of their risk points of total cost is when something is broken and they're not sure how to fix it, they also are calling a singular contractor on an emergency basis, and the solution, unfortunately, is mostly from that same contractor who is going to benefit. So is there a way to create a very quick stripped down version of biddable documents? In our core business, we generate plans all day long, and that's what we do. So could we do from the twin a quick snip of the problem, attach it into an RFP document, and then send that document to one or two vendors to give them pricing here, look at troubleshoot on the twin, get the historical data, and then bring them out to the field to figure out what they need, the parts and pieces. Shrinking the timeline is going to directly affect the total cost of ownership, of maintaining these buildings. With the advent of sensors, we've reached this place where there are millions, if not billions, of sensor points. Just inside of a chiller might send 20 or 30 different points every second. So we have too much tech now that's becoming more of a burden, not an aid. So I think a lot of us live in the world where email was great, but now email has become a burden. So how do we move into actually running the building, clearing the alarms on a way that actually keeps our business continuity going and also starts to save energy? Those are your two main benchmarks of success. So we have software out there, not we, but the marketplace, where you can start to detect anomalies. Let the software start to monitor the sensor data. This is called fault diagnostic and detection. All of these are offshoots of how do we reduce the cost. Once you know your total cost of ownership, the next logical question is, are you sure you can maintain it, or how can you start to reduce it? And so we're looking at these, they're called fault diagnostic, where they just seek out anomalies. And what does that mean when for the last 2 years, your current was within this certain range and then it spikes? Does this mean the motor is about to go? Does this mean the transformer is having issues? So then that allows us to create a work order to do some predictive maintenance, which is much cheaper, of course, than emergency maintenance. The system architecture, just to give you a sense, is the game engine. You have lots of different ways to bring in data into, we've built ours around the Microsoft Azure cloud. Microsoft, Amazon, IBM, they all have massive different software platforms within these cloud platforms that can then start to parse and piece the data based on what you want to create. Eventually, we'll use Microsoft's cognitive services to ask those questions about how can I better operate my building? What's my single point of failure? What color is painted in room 105? And so these are really basic questions that we'll pull from the cloud. So the ultimate goal as well is to start to reduce our carbon footprint, and we're also trying to look at that ROI. So with TCO, we're in a paradigm today of money, but there will be a paradigm that we're moving into, which is going to be about how do we reduce our carbon footprint, and can we reuse our buildings versus build brand new buildings? And so these type of questions can be answered by people now, can be answered by master plans, and they need to be answered by architects and engineers at that higher campus level. But then on a simple building level, can I run my conference room more efficiently? Can I repurpose a conference room from a conference room to a admin? We have and it's all of this is going to be to drive down our costs, which will also drive down our carbon footprint by dropping our energy. One of our clients, we asked if we could go to unoccupied mode on a Friday at 1 o'clock in the professor's office building. And we could, because no professor was teaching or working in their offices after 1 o'clock on a Friday. We kind of know that anecdotally, but they were running it till 6 p.m. before that. And so we saved 15% there on the energy costs. Okay, I'm going to kind of jump into the demo and take you through a live twin, so bear with me. I'm going to end the slideshow. All right, and then hopefully you can see my screen. All right. Okay, so what we're looking at here is I'm going to take you kind of through a couple different buildings. So bear with me on here. You guys can see my screen, correct?
Hey, Raj, it's Colleen. We can see your screen.
Okay, thank you.
You're good.
All right. So we're going to go into, so this is a digital twin where we take the building, and what I'm going to show you right now is how the building operators are pulling in live data. This is live sensor data into about a 300,000 square foot school. And so think about how you interact with your buildings now with spreadsheets and dashboards. So if you wanted to see everything is green, everything is good, if I click on a sensor, I can kind of see this is the actual temperatures, everything's within range. And so these are things that we can start to really also bring into the twin. So this is how they're looking at the sensors to make sure that we are having all of our systems operating properly. You can turn on different layers, and then that will also turn on. I can start to turn off layers, and oops, sorry. And now I'm looking at the entire building systems only. So on the troubleshooting standpoint, can we troubleshoot with the twin here? If someone calls you and says, I'm hot or cold, can we go into that room and get a better feel of what's happening? If we have a leak, can I see where the piping systems are? Can I look at all these and go, okay, looks like things are working, things are not working. So this is where we're trying to make it asset centric and troubleshooting here. Total cost of ownership is always our theme, is how do we drop our costs? And someone going out to site to investigate when they could start to check in here is where we really want to start to get deeper. All right, let me go into this twin. Let's see. I'm going to show you a couple other samples. It's this. All right, so this one is our, it's also an industrial type client. And here we're going to turn on and off different layers. And what happens here is, you know, basic information we're just going to host in here for the efficiency. So if I want to just know what the information is on a the asset when it was installed, we're going to keep all that information in here. Sorry, this control panel's in the way. So let me go back to this model. Or is it the beta site? Okay. So as an example, if I want to look at this guy, I can pop this out. So you get an alert saying something's wrong, we can pop it out and we can go to its cut sheets and pull that up as an example. So within seconds can we get to data to help the operators drop their costs down. And that is the ultimate place in how we're doing the TCO on that. Now let's look at KIPP's specific example. So with KIPP, we've got their 4 campuses here. And looking at their, we'll go into Hamilton. So one of the inefficiencies that we removed was just their building. So if you look at how their plans were captured in the past, they just wanted to get a, what is the most recent set of plans. So we're just now categorizing these by time. So there was their original renovation, then they did a media center demo, then they did a storage project, then we did a media center project. So these simple levels of efficiency, if you wanted to just click it, they've got all their plans, and then we can just open them up, host them, mark them up right here. So this is also added to the efficiency of how these systems are working and not working. So this is, again, a small little piece of adding to the overall efficiency of the system. So I'll close that. All right, so here's one of their buildings that we work with. I'll turn on the mechanical systems. I'm going to turn on the electrical systems. And then if I close this and if I start to go deep into this, and just simple things like getting a better feel of what is operating and what is not. So now what we've done is we've overlaid heat maps for them. So if you wanted to see what was behind on its preventative maintenance, which ties into their work order systems, it will go red, all the different systems that are behind on their preventative maintenance. So this is something that we're going to work with them on and say, okay, well, everything's running, that's fine, but now we need to kind of figure it out. Do we have any open work orders? Yes, we have some open work orders. This is all just taken from their work order system. Do you have anything that's within 5 years of their useful life? No, everything looks good, so we don't need to start budgeting for capital planning. Well, I want to jump into my CMMS, and this goes right into their School Dude system, which is their CMMS. So it's another quick interface to get into there. So then we start looking at the total cost of ownership. So this is all live data feeding in. So in 2019, they spent $1 million on their building. Electricity, water, groundskeeping, all of this seems in order. If I go into MEP maintenance, November is their biggest month. So now as we start to gather all this data, the analysis will start to begin next. Well, is that normal? Instead of me clicking through all the different years and going through now 2020, looking at MEP maintenance, November was a very low month. So this is where we can now, again, people like us will start to analyze this data and get a better sense of what their costs were. Now, from a year-to-year basis, it's about the same. So it's really just about how they lent out their contracts. How does it all get in here? So if we go into their contracts page, what we're doing is trying to normalize this based on square footage. And as you start to see what their costs are per square foot, and everyone's going to be a little bit different, we can then drill in. Let's take custodial as one, I think. Where's custodial? If I go into custodial, it's another way to redisplay their data from their accounting systems as we start to tie in. So here we'll just kind of have a bar graph. They have a bit different opinions on this. So we start looking at the different contracts that were done by month. And if we wanted to edit them, we can go in and edit those contracts just to get a sense of what they are. So if I click on it, FY21 Sandy Handy drip trays, trash dumpsters. Do we need this level of granularity? No, but you have this level of granularity if you wanted to go in and just start to resort by vendors, resort by your trash company costs. But just starting to get the data in a palatable format, and then we start to analyze it is the next iteration. Moving on into capital planning. So with capital planning, what we were doing in the past was starting to look at every 5 years doing that condition assessment, but can we plan from an asset? So if I look at the mechanical systems, all your main units, we have a remaining useful life. We can sort it by that. We have quantity. We can sort it by that. I've got 90 diffusers. So there's so much rich data that we've drawn in, and we can now bring in either local costs or costs from means to give you a sense of your replacement costs. And if we do preventative maintenance, we can start to adjust these useful life years, and you get a better sense of your points of risk. Anything with a 1 or a 2 is typically a point of risk. Then from here, we'll start to build out profiles, which we haven't done yet, but the summaries, and generate a FCA report in real time. There's no reason we need to be doing this every 5 years when all of the asset data, is built in already into it. So that's kind of this TCO level, going back into these different work order systems where we pull it, capital planning, but it all is here from kind of a virtual troubleshooting where we start to put it. Eventually, we can start to bring in other parts and pieces like furniture, like plumbing. And what we do here with this type of putting in these different assets is we can then turn things off. So if I turn off my mechanical and I go in here, start looking at the overlay, if I remove the useful life, if I start looking at the overlay of leaks and how we can shut things down, all of those can be done in taking a look at the digital twin. Let me go ahead and turn off I'll turn off the electrical too. So let's say we had a leak here in one of these bathrooms and your operators needed to quickly find where the shutoff valve is. So we could do it the old way, which is just opening up different ceiling tiles and hoping we get it. But we can see here there are some shutoff valves right here, so we can at least guide them to that. Now, when it's we do have to keep the digital twin and the real twin in parallel. So if they're not here and they're really over here, we just update it, let us know as the operators, and we move the valves over. Things like this is all taken from the as-built, and hopefully it is built the way that they told us it was built, but underground, looking for underground piping. It helps with some of the efficiencies of cutting and figuring out where things are. One of the things that changed for our customers is that we think of buildings by systems and more vertically by room numbers, not as much by graphs and some of the dashboards. So that's kind of where we are in looking at the twins. And now as we bring in the sensor data, we bring in the financial data, we can start to generate all kinds of different maps and these kind of things. How does this all get in? If you give companies PDFs, it can just be drawn in. It's not a construction level BIM model. It is a facility level BIM model. So while we like to be exact, we don't need to be within millimeters. This valve can be within just a couple inches and drawn, so you get a general area of where it is. And that kind of is how the demo kind of goes. So I don't have too much left. We can go into the questions, but as far as conclusions, we need a better way. We need to start thinking of troubleshooting virtually, getting a better handle of costs. I'm with way too many customers where there's just too many emergency requests, and it's just not feasible because the costs of these are very, very detrimental to people's budgets and consistency. The initial data lift is large and there's no easy way around it. But once it's complete, then it is complete. You're building, when you build a digital twin, it's similar to building a real building. A lot less time, a lot less effort, but you do need to build the data profile of that building, and then you can start to manage it and optimize those systems. Over time, you're not going to get more people. As many of our higher ed clients, they're adding lots of square footage, but they're not complementary facility staff to do that. So this is where we need a better tool, and the digital twin is where we have found a lot of success with KIPP. Nothing is perfect, but we're trending towards solving things on the computer first before you go out to the field. The guys in the field can go out with the right part and piece is our vision before they go out to the field to figure out what's wrong and then come back. All of this will start to drive that total cost of ownership into something that's more manageable and also predictable. All right, well, thank you, and we'll open it up for some questions now. Anything else, Colleen,
Okay.
Billy?
Not right now, but we do have quite a few questions. Our first question is, describe what a game engine is and how it is used relative to Cyclops.
So you can use the different suite of tools that are in different BIM products. what we have found is by taking it into a game engine, we just need a few simple point and clicks. I mean, if you look at what I'm doing here, the game engine piece, let me close that. The game engine piece is about I'm walking through like a game, and I'm just hitting an object like a dialog box, talking to it. That's it. So that's kind of what's shifted, is you don't need a very sophisticated construction or design software package. You just need a very stripped down interface viewer that goes into your database. So how can we so that's what the game engine is. There's a few game engine companies out there. The biggest one that we use is a Unity 3D that also allows us to move into the AR side of this as well. And so that's kind of a piece of this too.
Okay, thank you. Next question. Is Cyclops an FDD system, or does it communicate with the client's existing FDD platform?
So Cyclops is more of a visualization tool for the FDD system. So we would communicate with your existing FDD, and as your fault diagnostic gives you a alarm or a spark, however you want to define it, then Cyclops can ingest that and then show it on top of the particular unit. So in this case, if this was a spark, this would just say fault detected. We could have that go red, and that could land right on top of this unit. So as you're a building operator, you kind of log into your building in the first part of the day, and you can see every fault that's there that's red, and just go and deal with those.
Okay, thank you. Next question. Are there what-if scenarios that can be run once the data is in the model?
So
and
that is...
There's a little follow-up to that, so I'll read that as well. Providing a little more clarity to my question about scenarios. Can a scenario be run so that a TCO analysis can be formed that will compare a chiller boiler replacement versus waiting several years?
So the short answer is that's where we want to take it. So to answer that question on analysis, as long as it's governed by a set of equations, then we can start to program it in. So to answer your particular scenario, I want to switch from a chiller. I want to go ahead and replace my chiller boiler. So as long as we can ingest the sensor data that starts to tell us what our current consumption is for the last 10 years. If I have sub-metering data on that chiller, let's pretend this is a chiller right here. Oops. Then I know what I'm going to use. Then I'm going to overlay that with the new chiller, and that uses kWs per ton. So if my chiller is 500 tons, I know how much kW I use. I can put those same usage profiles, and then I can start to run those scenarios. Now, what Cyclops, that will be done in the background based on probably on the Microsoft platform. What Cyclops will do then is have a internal mechanism where you ask those type of scenarios, and then we come back, we send it out to different platforms to analyze, and then we come back and display the answer. So this twin, it's part graphical viewer, it's part general interface to get all of the different scenarios in. The answer is, as an engineer, I'm hired to do that exact same scenario. So how do we program that in there? What are the inputs that I would need to answer that question is what we're trying to host in here as well. So hopefully that makes sense. It is the vision, but it does take lots and lots of data to get to that answer.
Next question. Can this system be used to help designers make value-based decisions prior to construction? Value may include sustainability questions and net zero energy.
There's definitely, that's I think what we would like to do, but there are a lot of different energy modeling type platforms that are already doing that. So our focus is not much on new construction, but how do we optimize the existing buildings? 95, if not 99% of the buildings in existence exist, and we really want to optimize their operations. It is the biggest opportunity for reducing our carbon footprint. While net zero is awesome, we need to have new net zero buildings. We also need to come to a place where we can convert our existing building stock to net zero. That's where I would like Cyclops to be used as a tool to start giving us those items. If you were asking Cyclops on this building, Dunbar High School, how much area do I need for solar arrays to use 5% of my building use on renewables? Those are the type of questions that we really want to focus as we start to work on our existing building stock. But there's better platforms, better applications for running those net zero analysis, energy modeling software out there that's probably more useful.
Okay, thank you. Our next question, do you follow a process to confirm the assets in the BIM model are identical to the assets in the CMMS? Physically confirm the BIM model assets were actually installed so that the CMMS is the single point of asset truth?
That's a great question. So normalizing the asset naming convention and also what is the single source of truth is the key. The beauty of this, though, is we can change it if you find something else that's different. So in your model, if something is called, let's just take, for example, this valve. If you have this in your CMMS, so if it's here in Cyclops called V1 and your CMS calls it V75 or something by the room, we do need to associate those two and then make one of them the only name. So our process is we start with the PDF plans or whatever drawings you have. We draw it up into a BIM model. Then we assign all the asset names by what's in either the CMMS, working with our clients, or what's written on the field, or what's in the building management system controls. Often you have those three different names. What I've seen is for HVAC units in particular, this might be called RTU1, but the room level units might be called by their room names right here, like this is a room. So what we need to do is, you only need one name. The other way we're doing it is we've skipped QR codes. I think QR codes are great, but they're kind of a common place right now in time. But what we want to shift to is a actual GPS XYZ longitude, latitude, elevation coordinate, because every piece of equipment, every light has a unique coordinate in the world. So your coordinate system should be your single piece of corroborating data across your many platforms. And especially with lights, that makes it much easier if you have an XYZ for a particular light.
Okay, just a reminder that we do have quite a few questions, and I don't think we're going to get through all of them. The questions will be forwarded to Raj, and he will reach out to you to answer these one-on-one. Okay, our next question is, what type of software technology do you use to tie the school's accounting data, work orders, costs, etc., into Cyclops?
So every software generally has what's called an API. It's basically some code that allows a handshake. The key with Cyclops is it is a one-way data flow. We will receive the accounting information and then we will visualize it. We will not make changes going back into your accounting. That allows the protection of that data, and it doesn't change your data processes. So based on what we want to see on the total cost of ownership, on the graphics of how we want to set this up, then that's what you will port that out. In essence, at the simplistic level, everything is a name, a cost, and a code. And if we kind of get those three, we will have to tailor it. But once that's there, we've worked with multiple different software systems, and it does take time to get it right. And then you start to normalize it into what you want to see. If your particular coding, you don't want to see custodial, or you want to see that broken down into landscaping, snow plowing, or by region, then as long as it's coded in your other software, then we can visualize it separately. But that's the key. It's a one-way flow. And once that data is ported, we have to now normalize it. Everyone's going to be a little bit unique. You got to do it once, but once it's done, it's done.
Okay, thank you. I think we have time for a couple more questions here. Many owners have concerns about the initial lift costs. Because detailed BIM models are not free, what are the potential offsetting costs for this method versus the old way? Are there any documented savings?
So the ROI studies that we've done with our clients, similar to KIPP, is when something goes wrong, the simplest way is to start to categorize what is your average work order fixing time. So when I have a work order initiated in whatever system, how long, if you can categorize it into, simple, maintenance, critical, emergency, how long does it take for you to resolve it? The longer you have the buildings down, the more it costs you. So some of our ROIs have been leaks, where there is a ceiling tile that's leaking, and instead of going in, one of the specific examples is they opened up the ceiling tile and there were some pipes that were wet. They were about to cut those pipes. They went to Cyclops, they looked in, saw there was a roof drain above those pipes. They checked the roof drain, and it was the roof drain leaking on the pipes. Now, I don't have a good ROI on that, but we all know, they know that they saved at least a day's worth of work of cutting these pipes, and they were able to troubleshoot faster. The initial lift, if you have a project, a new construction that has a BIM model, you've paid for most of the lift. Now it's all about data integration with your different software packages. To draw it in, we're generally in that 50 cents to 75 cents a square foot range, depending on the complexity. To just, you hand us PDF files and then we draw it into the BIM model. We don't need a perfect BIM model, because we are what's called a facilities BIM model, and it's for the folks to use out in the field, not to actually do construction, to do takeoffs, and that's why you can get these things up a little bit faster. We use a completely different engine to start to populate all the data that goes into these items. So, with the specs, all of that, it's a drag and drop scenario for these.
Okay, it looks like we have time for one more question. How challenging has it been to obtain a BIM model of a facility?
It's very challenging. I think it's all turned over from contractors as part of their handover documents. But you have operators, when building owners don't have the latest version of, let's say, Revit or Bentley, and so it's hard to open that. You need someone trained on that, because they're very complicated, excellent programs, but they're hard to work. So what we're recommending is, this is an HTML site. This is basically based on a game engine. You're just pointing and clicking. You don't need to know a lot of software. So even if you don't have that BIM model, you can draw it in at a very quick pace to get us up to a digital twin model. But start thinking about your buildings as buildings, not as much as systems. It's very important you start to look at buildings like buildings. And this is how I view a building. So hopefully that's there. I have a couple more minutes.
Okay.
Ask more questions. Sure.
Yep, you have a few more minutes, so we'll take one more question here. Is it cost effective to create the digital twin for an old 50-year-old existing building?
So I would say it's cost effective to create the digital twin if that building is costing you a lot of money year to year. So by laying out this TCO profile, and if you know that building and this is a simple thing to do for the last 10 years. If it costs you 200,000, 300, 400, and you get a simple graph of what its escalation, at some point you're going to have to answer to normalize it, or you're going to have to say, why can't we reduce these costs? So the answer is, it is worth it if you're seeing more than a 4 to 5% increase per year in your operating costs above inflation. And operating costs is not just your electricity and your plumbing, but you're seeing more and more items break on it. Your work order time takes longer. You're going to have outdated parts and pieces that you won't be able to find easily. If you have a system with refrigerant that has been banned, like the R22 system, so that costs you a lot more money. So all of that type of information can be hosted in the digital twin. And the answer may not be what we think, but that's how we need to start to come to a singular place for all of the data. Hopefully that makes sense.
Okay. Well, I'll be sending you the last 10 questions that we were not able to get to in a report here shortly. So those who asked the questions, you will be hearing from Raj. So Raj, thank you so much for taking time today to do our presentation. And to our attendees, as always, thank you for taking time out of your busy schedule. So until we meet again, stay safe, be healthy, and be kind to one another. Thank you so much for joining us. Goodbye now.
Thank you.